For question 21, we are going to evaluate the following limit if exists. So question A, we're going to find the limit of a function where x minus 2 over x power 4 minus 16 when x approaches 2. Then for this question, our first attention will be going to substitute x equals to 2. You'll notice that when we substitute 2, you'll get 0 over 0. So this will be an IDF form. So for IDF form, we have to simplify our function here by factorization. So as we can see our polynomial here, we can factorize it by using the concept of a squared minus b squared. So our a squared here will be equals to x power 4. Our b squared here will be equals to 16. So our a will be x squared, then our b will be 4. So we try to factorize this function. And we notice that we can factorize it one more time for this x squared minus 4x. This factor is in this form of a squared minus b squared too. So now my a squared is x squared, so a will be equals to x. B is 4, b squared is 4, so b will equals to 2. So it will become x plus 2, x minus 2. To factorize this x squared minus 4. Now we notice that our function can be simplified, where the factor of x minus 2 can be eliminated. Then we can attempt our limit again. We can try substitute our limit again. So now we can get 2 squared plus 4 and then 2 plus 2. So which will equal to 1 over 32. So notice that our limit notation will have to be followed until we manage to substitute our x equals to 2. So for this level, when we substitute x equals to 2, this notation we no need to write it again. So what is important concept here? For limit at the point when we have IDF form, we have to know how to factorize it and simplify the function. Then only we evaluate our limit and get to the answer. For question B, they ask us to find the limit for this function at infinity when x approaches infinity. So when we can try and substitute our infinity here, we can notice here this is infinity over infinity. So when we have infinity over infinity, it is an IDF form. So in order to solve IDF form for limit at infinity, we have to divide by the highest power of our denominator here. So our first step here, we're going to expand it first so that we can divide it one by one. So our answer, it will be equals to 3x minus 2 minus x squared over x squared minus 6x plus 9. So for this form, we will start divide with its highest power from its denominator. As we can see here, the highest power from the denominator will be x power 2. So we will divide every term of this polynomial with x squared. Then we simplify our function. It will become 3 over x and then minus 2 over x squared minus 1 over 1 minus 6 over x plus 9 over x squared. Then we can try to substitute our infinity. So this time we can get our answer 3 over infinity minus 2 over infinity minus 1. So it is no longer infinity over infinity again. So 6 over infinity, then plus 9 over infinity. As a number, divide as infinity. So 3 divided to infinity, it will get 0. So our final answer here, they will give us negative 1. So what is important here, where when we have IDF for limit at infinity, we have to know if we get this is polynomial, we have to divide by the highest power of the denominator here. So this is our concept to simplify our function in IDF form. Then we can try to attempt our limit, substitute our limit and operate it to the answer. So that's all for these questions.